Okay, so we're gonna look at loops. As I mentioned, loops are very useful because we can repeat something that we want to do more than once. But in order to do that effectively, we have to combine a few different components. So we're going to be using conditional logic, we're going to be using variables, and we're going to kind of be using a few different things stuck together in order to make our loop work. So I'm going to kind of go over the syntax a bit first, and then we'll look at a couple different examples of how we can use the loop. I'm going to use P5 to demonstrate most of this stuff. So I'll call this loop example, and this is the 18th. So I'll add this to our class collection. Okay, so we've already learned conditional statements, and we know from doing a conditional statement that this is what the basic code looks like. We use the if keyword, and then we evaluate a condition, and then depending on whether that condition is true or false, we run some code inside the two brackets. A loop statement basically works exactly the same way, but it can do the code in the brackets more than once, or less than once. If sometimes the loop condition is 0, but most of the time we're going to be doing it more than once. So when we use an if statement, we're going to run a block of code, but we're only going to do it one time. With a loop, we're going to run it as many times as we want. But that's where our conditions come into play, is that we have to set up our loop to run the number of times that we want it to run. And so JavaScript has a few different types of loops. The one that we're going to use the most is the for loop. That's the one that is generally the most useful, and it's the easiest to write because it puts everything into one line. So we don't have to look around for our different components. But we're going to start looking at a while loop because this is the one that is the most similar to the if statement that we've used in the past. And we'll use that as an example to kind of build up how a loop works as opposed to an if statement. So I'm going to do an example here. We're just going to have an if statement. So with our basic if statement, we start with the keyword if, and then we have a condition. So let's start with the condition. Let's imagine we want to draw a circle, but we only want to draw it if it's on the screen. So let's say we have our variable. Let's say we just want to know if 50 is less than the width. Then we're going to draw an ellipse at 50. We're going to replace this with a variable in a second, but just as an example. So with our conditional statement, we're saying if this thing is true, if 50 is less than the width of our canvas, then we want to draw the ellipse. So we can imagine a condition that wouldn't be true. If we asked if 1,000 is less than the width, that wouldn't be true because the width of our canvas is only 400 pixels. And so 1,000 is larger than the width of the canvas, and so we do not see the circle here. So depending on whether or not the condition in our parentheses is true or false, that's when we will either use or ignore this block of code. So that's our basic if statement. But we can change this by adding a conditional or a loop statement like while. And so we can see a while statement here. What I can do is just replace this if with while, and everything else stays the same. The problem with this is if I run this code as is, I'm going to crash my browser. So one of the things that we have to keep in mind when we're writing loops and certain control structures in programming is that our computer is just going to do exactly what we tell it to do. It's not going to look at this code and say that doesn't work. This will crash your computer. It's just going to run it. So if I run this code, like my browser would stop running. Basically, it would have a Stack Overflow. So that may happen. If that happens, just go up here and go to Tools and go to Task Manager. And the task manager will show you all of the different things that are running in your browser. And if you crash your browser, you will be able to see like this tab probably, or no, what tab are we on? We're on this tab. You'll see this tab, these numbers will look kind of crazy. Like it'll say the CPU is like 100% or something like that, because it's just running this code forever. And it's never gonna stop. So the only way to get out of it, if you do that, which you probably won't do it, but just in case, you just click end process here, and if you'll see what happens is it just kills that tab, and then you can reload the tab, and then you can fix your code, and everything will go back to normal. So how do we prevent that error from happening? We have to create conditions for when the while loop starts and when it ends. So let's create a couple conditions. So let's say we want to start at 50. We can define a variable that starts at 50. And so instead of 50 here, we'll put in the x. And then we have to change the condition. So at this point, our while loop is still going to crash if we run it. What we have to do is each time we draw the ellipse, we have to change the value of x so that eventually our while loop will stop running. So I'll put x here, and then I'm going to say x plus equals 50. And so what that means is that each time I run my while loop, I'm going to move 50. I'm going to change x by 50 pixels. And since x is going up, eventually x will be larger than the width value. And so our while loop won't crash our program. So if I run this, notice that we draw a whole bunch of ellipses. So that's the difference between the for loop or the loop statement. Sorry, this is a while loop. That's the difference between the loop statement and the conditional statement, is that the loop keeps going as long as our condition is true. And so let me change this width value, because right now it just looks like it draws circles across the screen, which is true, but it's designed that way because I want to cover the screen with circles. But let's say I only wanted to draw half of the screen with circles. I can change the ending statement. So now as soon as x is no longer greater than 200, then it's going to stop. So let's also draw x on the screen just so we can see what it looks like. So I'm just going to do text and put x at 50/50 as well. Oh, I need to put x there. So you can see our while loop is taking x starting at 50. And then it draws the first ellipse, so that's that first one right there, which is 50. And then it draws the next ellipse, so it adds 50 to x, and then it goes back to the beginning. So that's what the loop part means. It loops back to the beginning of this section of code that starts wherever the beginning of this bracket is. So after it adds 50 to x, it goes back to the beginning, and it evaluates this condition again. So x is now 100, and so it's saying, is 100 less than 200? And that's true, right? So then it does the whole thing again. So now we draw another ellipse right here at 100, and then we go through and we add 50 to x. X is now 150, and so we go back to the beginning again, and we evaluate our condition again. So we say, is x still less than 200? And if x is 150, then it is. It's still less than 200. So we draw another circle. And so that's our circle right here. And then we do the whole thing again, except this time, now x is 200. So when we go back to evaluate our program, 200 is not less than 200, right? They're the same number. And so that's why we don't get the last circle. If I change this condition to equals, now I do, because now I'm saying, is it less than or equal to 200? So now 200 and 200 are the same, and so we still run our code, but now x becomes 250, and so we don't do the last bit. Okay, so that's our while loop. And as I mentioned earlier, it's very easy to break your browser if you use a while loop, because if I forgot to put this here or I forgot to put this here, then I'm going to get a Stack Overflow. I'm going to crash my browser. So we use a for loop instead, and the only difference between while and for is that for takes our three parts. The first part, where we start with our x value, it takes the second part where we test a condition, and it takes the third part where we change or we update the value, and it puts them all into one place. So it's a lot less likely that you'll make a mistake. You could still make a mistake. You could still crash your browser. It's not the end of the world. You just reset the browser and then, try it again. So let's write the same thing as a for loop. I'm just going to put it right down here. So with a for loop, we start with for. And so for, in this case, is like our while or our if. It's just the keyword that we start with. But then in our condition, we're going to put all three of these conditions in here. So they're all in the same place. So I'm going to grab this variable x, and I'm going to paste it in there. Then I'm going to grab my conditional. So this is as long as this is true, we keep looping. So I'm going to copy and paste this in there. And then one thing that's a little confusing is that I do need a semicolon at the end of here, but I don't need a semicolon on the last statement because it's the last statement. So you don't really need the semicolon there. So I'm going to copy this last statement, and I'll put this in here. And I'll take out that semicolon. You don't have to, but that's how you will see for loops written like 95% of the time that you write a for loop. So then I'll put my code in here. And this time I can ignore this last line because I don't have to change x anymore. That's part of my for loop. So I'm just going to take these two lines and put them down here. And then I'll change the y value just so we can see the difference. So I'll move the y down to 200. Oh, that was the size, not the y. Okay, so now we've got two different loops, but they use the same basic concept. So again, the for loop, the only real difference is that all three of our conditions are in the same place. So that just makes it easier to see where our for loop starts, which is right here, how far we go, so the condition for when it ends, and then how much we change by. And we can change all of those values. So if I want to make more circles, I can say x equals 10. Or sorry, if I want to start in a different place, I can set x to 0. That'll move everything over. I can set x to 100. That'll move everything to the left. So we can change that number to whatever we want. Let's set it to x is 0. We can also change this number to whatever we want. So this is changing where on the page we're drawing the circles. This is just one example. You don't only use loops to draw stuff across the screen. You can use them for anything that you want to do more than once. So we'll show different examples of that in a second. But I can change this as well. So if I change this to 400, then we'll draw circles all the way across the page. I could change this to like 600. And so now there's some circles over, that we can't see, but there's no real reason to do that because I can't see those circles. And then I can also change how much I increment by. So if I change this to 10, I'll have lots of little circles. If I change this to 100, this is how far I move after each loop. So this is how much I'm changing by when I finish each loop. Okay, let's actually change this to 300 because I'm going to do a couple more examples. Oops, I mean 200. So we're going to do a couple more loops. What did I do the first one at? 50. Okay. Let's do the first one at 100 just so we're using some even numbers. Okay, so we're going to do a couple more examples. Any questions before we keep going? Okay. Okay. So another way to do a loop is when you guys have been working on your projects, there have probably been times where you're like, oh, I want like 10 circles, or I want 50 circles, or rectangles, or whatever it is you're drawing. And you probably thought, there should be an easy way to do this, but we haven't talked about loops yet, so you might not have known. And you might have drawn like a whole bunch of circles. So another way that you can do a loop is by identifying which thing that you are looping and then recreating the loop. So the way that you could do that, let's imagine that I had a bunch of circles. I'll use circle. I keep using ellipse because there used to not be a circle.
Professor, so with the assignment, I don't know if you remember that I did like a page that you could draw in it, that you told me I could like get in the future a better technique to replicate the lines.
Yeah.
It was this.
It was this.
The loop?
Yeah.
Okay.
Yeah. Yeah, actually, that's a good example. Let's use the lines that Victoria used. So let's say we had a line. Let's say we just wanted to fill our whole canvas with lines. So let's start with a line we'll start at 0x and 50y, and we'll go all the way to the other side, so width, and we'll stay at 50y. So we have a line, and so before you had a loop, if you wanted to change this line, I would just go, I would make a new line, I would copy and paste, and I would, do this. So now I have 2 lines, and so now I would copy and paste that, and I would go to the next one. So I'm just increasing y by 50 each time. Okay, so then I would draw another line, and this would get very tedious, because I'm just drawing lines. Maybe I would make mistakes like this, like one of my lines, I forgot to change the number, so it looks wrong. And so I'd have a bunch of lines, and then, maybe at a certain point I'd notice there's a pattern. So instead of copying and pasting 1 at a time, I'd do 2 at a time, and I'd say, okay, this is 250, and this is 300. And then eventually, after copying and pasting over and over again, I would have lines filling up my whole page. And so that's fine, when you're first starting to learn code, you're just doing whatever you're gonna do to get the design you want. But the reason code is fun is because we can take something like this and we can figure out what's happening and then turn it into a much simpler statement. So we can look through this code and we can very easily see, first of all, that x is always 0. The first x1 is always 0. So we don't have to change that, so that's easy. y1 is always changing. Okay, so we notice that we need to change y. x2 is always the same, so we don't have to worry about that. And then y2 is also always changing, but it's the same as y1. So it might not be the same if your lines were at a slant. They might be a little bit different. But we can analyze our code and figure out what's changing. So the only thing that's really changing is this y. So we can say, well, what if we just say variable y equals 50? And now, instead of, first of all, we can rewrite this line by just setting y for both. So that's a lot easier. And so, okay, maybe I can do that for all of my lines. So now I can do this one. The problem there is that, I have to add 50. So I'd say y plus 50. Okay, so now I'm getting somewhere, but then I go to my third line, and now I have y, but now I'm saying y plus 100. So I'm basically ending up doing pretty much the same thing, but it's a little bit easier because I have y instead of having to, do the math each time. So now I'm like, okay, if I'm going 50 and then I'm going 100, I'm really just adding 50 each time. So instead of adding to y each time, maybe what I can do is increment y in between my lines. So instead of doing that, I could say y equals y plus 50. Okay, so then that works for the first one, but now I have to do it for the second one as well. Okay, so now I'm starting to get somewhere. And now instead of writing these lines, I can copy and paste, and it'll do the same thing. So I just draw a line and then add 50, draw a line, add 50, draw a line, add 50, draw a line, add 50. So this is, now I have 2 parts of code that are the same thing. So that's easier to do over and over again, but it still looks bad. I still have like a bunch of lines, a bunch of y's. They're all exactly the same. And that should really tell you there's a better way to do this. There's an easier way to do this. So now I just have to figure out, okay, so I'm always just drawing this line. The only thing that's changing is that y is going up by 50 each time. Okay, so now I can just create my loop. So I can think, all right, so I know I need a loop because I want to do something more than once. That's what you should think, is if I want to do something more than once, that's pretty much the same thing, that's when you want to use a loop. So I'm going to start with y equals 50. And so now this is the hardest part, is to figure out when do I stop. Because we've done this here, but we didn't have to figure out when do I stop. We just keep going until we've got our design. So the thing that's the hardest to figure out with a loop is, how do I know when to stop? So basically I want to keep going until I've left the canvas, right? So I want to go as long as y is less than height. Okay, so as long as y is still inside the canvas, then I want to keep drawing. This isn't always going to be true, but in this case, that's what we want. And then the statement to change is right there. This is how much we change y each time. And we can shorten this by just saying y plus equals 50. So now, if I put this line of code here, I literally just have to do that once. So I'm going to delete all of this stuff. My mouse is kind of buggy today. I don't know why. I might have to change the battery. Okay. So now, instead of 10 lines of code or 20 lines of code, I've got 3 lines of code. So it's a little bit trickier. We have to do a little bit of work to figure out what are the conditions that we want to do for this. But if we do that, now we can do lots of cool stuff. So if I want to change something, let's say I wanted zigzag lines or slanted lines, I could just say plus 50. And now I can change the whole design just by changing one number. And so this gives me a lot of control, a lot of things I can vary. There's a lot of cool stuff I can do with this now that I've kind of created the basic idea. And we'll look at that a little bit more next week when we do more with our loops.
For the third condition, I think is the word y plus equals 50. I thought you were putting like y plus 50, but you're putting the equal because it starts in 50, right? Like, what is the reason that it's plus equal and not just plus?
So that's a good question. So remember, when I create a variable, if I create a variable x and I say x plus 50, that math happens, but it doesn't change x. X stays the same. So when I say plus equals, what I'm really saying is x equals x plus 50.
Okay, I understand.
Yeah.
But you are giving it a name to y and also doing the math at the same time.
Yeah.
Okay.
Yeah. So I'm doing the math, but then I'm assigning it back to the variable. So the shorthand for this is x plus equals 50. Yeah. So if I just had y plus 50 here in my loop, I would get a problem because it would never actually change y. So y starts here. So y does exist, but this is what changes y. And if I never change y, my loop never ends. So I would get a Stack Overflow there. So I'm going to do one more example, and then we'll do some workshop time. So in all of these examples, we've been using x and y in the canvas, and that makes it easy to visualize what's happening with the loop. But most of the time when you're writing code and you're not necessarily doing visual code, your loops are going to be counting other things. So I'll show you what like 90% of loops look like is not x and y. Most of the time when we write a loop, it actually is going to look like this. We're going to see variable I equals 0. This is like the basic convention. I stands for index. Index is just a word that means like where you are in a list or in a series of numbers. So if you have 10 lines of code, the index refers to which line. So usually when we count in programming, we use I as a shorthand for index. And usually we just count however many we want. So we would say, let's say I want to draw a circle. Let's say I want 10 circles. I would say I is less than 10. So the reason I say I is less than 10 is because we start counting at 0. So in programming, we don't start counting at 1. We start counting at 0. That's a little counterintuitive, or it's a little confusing at first, but you get used to it after you do it a few times. So if we want to count 10 times, but we start at 0, we count in as long as I is less than 10. And then we just say I plus plus. So plus plus is like plus equals, but it just counts up by 1. So the huge majority of loops that you ever see in JavaScript and a lot of code are going to look like this. And that's a very, very common way to see a loop. So if we're not using x and y, we have to think about how do we convert this value into something that we can use visually. So I'm going to do 2 different things with this loop. One is I'm going to do the thing that we've been doing the whole time, which is drawing our circles across the screen. But I'm also going to use it to change the size of a circle, just to show that you can do both things. Okay, so the first thing I'm going to do is draw my circles. So I'm going to draw a circle, and I'm going to do 50, and then I'm going to move this down a little bit to 300 and draw it like that. So there we see our circle, but in this one we haven't converted our index into something that we can use to draw with. So let's do that now. So instead of putting x as part of our loop, I'm just going to calculate x here. So I'm going to say x equals I times 50. So I goes up by 1 each time we count. And so I'm just going to multiply it by 50, so that'll just move our circle across the screen. So I'm going to put x in for 50. And so now we get the same thing. So let's put the text, let's put those values on here just so we can see them. So we're going to look at I first. So I'll draw I at x 300. So you can see the index goes from 0. In this case, we don't actually see all the way across the screen because it is less than width. So let's just increase our width.
Hi, right? Oh no, never mind.
So I'll set the width to 600. That should get us across. There we go. Okay. So here we can see we have 10 circles, but we start counting at 0. So our last circle is 9. So this I value is just our counter. We just count from 0 to 10. And you don't always have to count up. You don't always have to count by 1. You can change all of those properties depending on the context. But this is what most loops look like. So let's also draw x on the screen just so we can see that math. And I'm just going to add 20 here so we can see it under our 10. So here we see the math that's happening. So when I is 0, x is 0. 0 times 50 is 0, because 0 times anything is 0. So then I becomes 1, and I times 50 is 50. Okay? And then we just keep going. So when I becomes 2, we count each time we go through the loop. When I becomes 2, 2 times 50 is 100. Hey, guys, sorry, do you have a question, or can we do that later? Okay. Do you have a question about anything?
No. One of my brackets was off.
Oh, okay. Okay, yeah. Okay, so each time we, draw our circle, we go back to the beginning. So that's the thing that we have to remember, is that we're running this code. Every time we get to here, we're going back to the beginning and checking to see if I is still less than 10. So eventually we get to 9. 9 times 50 is 450. And so we draw our last circle. Then I becomes 10. We go back up here and we see 10 is not less than 10. And so this is where our loop ends. Okay, so let's use it for a different component. So I'm going to draw a circle, but this time I'm just going to draw circles that get bigger as we go. So instead of x, I'm going to say variable s for size. And this time, I'll set this up, but we're going to have to do something a little bit different with this. So I'm going to say s equals I times 10. Okay, so kind of a similar thing, but we're changing the size. And then I'm going to draw a circle. This one, I'm going to just throw it in like the right corner over here. So I'm going to set x to 400. And I'll set y to 100, and I'll set the size to s. So right now it looks like one circle, because the biggest circle is being drawn on the top, right? So sometimes we have to figure out how to do the math in order to get what we want. So there's a couple ways I could do this. We could use the map function. That's an easy way to convert one value from a range to another. I'm going to do it a little bit differently, but then we'll use the map function. So one way I could do this is I could say, I actually want I to get smaller. So I could start with something like 200, or I want the size to get smaller. So I could start with 200, and then I could subtract I times 10. So now I get this circle that's getting smaller each time I draw it. Let's start with 100. And so then we'll get that. Okay, so each time we get a little bit smaller because I is getting bigger as we count, because we're doing I times 10, but we're starting at 100 and we're subtracting that value.
I don't understand the concept of I still.
Okay, so I is just the number that we're using to count. And you can see it right here. So do you see this 0 on the top line here? That's I. So I equals 0. Okay, so that's this 0 here. And we're we're saying I times 50, and then we're drawing a circle. So I times 50 is still 0. And so that's why we draw this circle at 0x here. So I times 50 is 0. Okay. So then, after we do this, we do I plus plus. So I becomes 1. Okay, so that's this I here. I is just a counter. It's just a variable. It doesn't represent anything except the number of times that we count. I stands for index, which means count. So if 1 is less than 10, that's true. We go through our code. Okay, so we draw our circle here, and then we go back to the beginning. So now I is 1. We add 1, so I is 2. I is still less than 10. So we do our whole thing again. So here's I at 2, here's our circle, and it's drawn at 100. Is that more clear?
Yeah.
Okay, so when we're using I, we kind of have to be clever about what we're using it for. So it's easy to map, x to position, but I is just a number. We're just counting up by 1. So another way to do this is using the map function. I could say variable size, and we could map I, and we know the range of I. The range of I is 0 to 9 because we're starting at 0 and we're going until we get less than 10. So we can map 0 to 9, and then I could map the size of the circle that I want. So let's say I want the biggest circle to be 200 and the smallest circle to be 50. Now it's going to map that range for us. So we can also use the map function here if we don't want to do some weird math. An easier thing to do is just map the value that we have in the range that we have to a different thing. We could also do color. So I could say R is map I from 0 to 9, and we could map it from 0 to 255, and then fill R. Okay, so we get a little bit of a gradient now because we're changing the fill as we go. And this is affecting everything else, so let's set our fill to white to start, and fill white here. Okay, so we can, when we're inside the loop, we can use these values to change anything we want over time. Oh, I'm also losing the text because the text fill is black. There we go. Okay. Okay. So, I think that covers everything we want to talk about. A couple terms just to look at. So, in the for loop, these are like the big words that we use for each one of these statements. So the first statement where we say I equals 0, this is called initialization. We're basically just like setting where we start counting. The second statement is called the conditional statement. This is the condition that ends the loop. And the last statement is just called iteration, which just means change. How much do we change it each time we go through? So this is a bunch of different examples of loops, and then we're doing some drawing. So we've already gone over this stuff. And so the thing that we really want to use loops for is creating patterns. And we'll look at some different ways to do that in the second part of class using randomness, so we can have like some different variation that's not controlled. But we can also just like make simple patterns here. So when we have our loop here, it's not that interesting to draw circles across the screen, but you can do more drawing within that loop. So let me actually do a new loop example. So I'm gonna do a new one here. And so the assignment for this project is to draw a series of windows. You can change this if you want. This is just kind of one of the general prompts just to get started. If you want to do windows, you can do windows. And the basic idea here is to not just loop across the screen, but to draw different patterns within the loop. So if I wanted to draw a simple window, I would start with my loop. So I would say for let or variable x equals 0, x is less than or equal to width, and let's say x plus equals 100, so I'll have enough room for my window. And so I'll draw a frame for the window to start. So I'll draw a rectangle at x, and let's do 50 for y. And the width of each window is going to be about 100. So we'll keep that in mind. So the width of our rectangle, let's do about 50. And then for the height, let's do like 200. Okay, so we've got some windows to start with. Let's increase this size a little bit. So let's say like 150, and then I'll say like 100 here. And let's make our canvas just a little bit bigger. And maybe we'll start over a little bit so that we don't overlap with the side. Okay, so we've got some windows, and so I can start to, design, the basic window. If I want to put like window panels in, I can make some smaller rectangles. So I could draw another rectangle, and I could move in a little bit. So I could say like x plus 10. And then I could say like, let's set a y variable in here actually to make it easier. So I'll say y equals 50. So I'll use y here. And so I'll say y plus 10. And then let's say for the width, let's say, I guess like 20. And for the height, maybe like 40, something like that. Okay, so we have a little pane here. We might need that to be a little bigger. Let's say 40 by 60. Okay, so then I'll copy that, and I'll move this whole thing over by like 60. Okay, so you can see I can start to create a little pattern. I might want this to be a little bit smaller actually, so let's do 30 here. And let's move over by 50, and we'll do 30 here. Now I'm a little bit offset, so I guess I need to go. I'll just make the first window, the width here. I probably would want to start actually with like a variable for the width, so I can calculate this easier. But let's just go with it. So I'll just move this over a little bit. I think that'll look okay. Yeah, that looks okay. All right, so then let's put some rectangles below that. So I'll copy and paste these guys, and then I'll say y plus 60 for those, or maybe 80. And I'll make these guys a little bit taller. So I'll increase the height of those rectangles. Okay, so this is starting to look okay. It still looks a little goofy, but you can kind of see how I can start to create these patterns. So I'm basically doing one drawing here, like we did our self-portrait or other drawings that we've worked on, but by using the loop, I'm repeating it multiple times. So that way I can create a pattern. You could create, your pattern doesn't have to be windows. It could be like, some other type of design or drawing. But that's a very useful thing to be able to do for lots of designs that use repeating patterns. So we'll use randomness a little bit in the next later in class, so you can add in a little bit of like differentiation between the different windows. But for now, we can just start with that. You can think about if you want to work with the window topic, that's in the assignment. There's this link to this Windows of New York website that shows all these different windows that you can find around New York. A lot of these are pretty complicated, so you probably wouldn't want to try to design the whole thing, but you might do something that looks kind of similar, or the kind of basic outline. But if you think Windows is not that interesting, you could do any other different type of design that you might prefer, as long as you have this repeating pattern. That's the basic idea for the assignment. So I'll stop here, and we can do some workshop time. Let me know if you have any questions. If you're having any issues, I can come around and take a look. As I mentioned, we'll talk a little bit about randomness in the second half of class, so you can add some variation throughout the pattern. But for now, we'll just get started with those. Any general questions on anything before we go to workshop time? All right. So I'm going to stop